Okay, so here we are given a function f of x, and we are going to be asked to evaluate these expressions on the right-hand side. So first and foremost, let's look at the limit as x approaches 1 of f of x. So as x approaches negative 1, which is about right here, x is equal to negative 1, what value does it look like f of x is approaching? So as x gets closer to 1 from the left, and as x gets closer to 1 from the right, it looks like f of x is approaching a value of 0. And so we would write that over here, where the limit as x approaches negative 1 of our function f of x in red is going to be equal to 0. Let's go into the next one, and I'll erase a couple of lines here to make it a little bit more clear. How about the limit as x approaches 0 of our function f of x? Well, again, as we approach x is equal to 0 from the left, and as we approach x is equal to 0 from the right, it looks like the value of our function is approaching 1. And so we would say that the limit as x approaches 0 of our function f of x is 1. How about the next one? What is the limit as x approaches 3 of the function f of x? So x is equal to 3 is roughly about right here. And as we approach x is equal to 3 from the left, and as we approach x is equal to 3 from the right, we see that the value of our function f of x seems to be roughly about 5. Note that there is a discontinuity here, meaning that f of 3 does not exist because we have a discontinuity here. This is right here, a discontinuity. And I can see that there is no point of this graph f of x in red where x is equal to 3 is defined. And so while we would say that the limit as x approaches 3 is equal to 5, we would say that the value of f of 3 does not exist. Let's go ahead and move on. Let's look at the limit as x approaches 8. So here is x approaches 8. Here's the line right here. And as x approaches 8 from the left-hand side, it seems to be going down, 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 down into negative infinity. And as x approaches 8 from the right-hand side, it seems to be increasing, increasing, increasing to positive infinity. And so as x approaches 8 from the left, it looks like we're going to negative infinity. And as x approaches 8 from the right, it looks like we're going towards positive infinity. So therefore, we are going to say that the limit as x approaches 8 also does not exist because the limit as you approach from the right and the left are not the same. I'll say limit as x approaches 8 from the right is not the same as the limit as x approaches 8 from the left. Let's look at the next one. How about the limit as x approaches 12 of f of x? So here again we see another discontinuity here. Discontinuity. But the difference is that at this point, where x is equal to 12, we see that the function is defined at x is equal to 12 at whatever this value right here is. And so as we approach x is equal to 12 from the left, and as we approach x is equal to 12 from the right, it looks like this value is going to be approximately 1. But the value of f of 12, this should actually be f of 12. The value of f of 12 here is going to be, it looks like, about 2. So note that the limit as x approaches 12 is 1, but f of 12 here is 2. So the limit can be a different number than the actual value of the function. Now see if you can do a couple of the examples on your own.